Hey, what's going on? Welcome to another episode of AngularAir. I am your host, Justin, and on today's episode, we're going to learn how to unblock our stack. Not quite sure what the details entail on that, but we're going to find out here real soon. So let's say hi to our panelists, then we'll meet our guests. We have multiple guests today. Some guests are panelists as well. So ghoulist, I think is the term. So let's get into it. First, let's say hi to Alyssa. Alyssa, how's it going?
Good to be here. So excited. Hello, everyone.
Hey there, hey there. I think Mike will be joining us, so he'll be a little late. So we'll say hey to him when he shows up. And our guests today, we got three of them. One of them is our resident panelist, Bonnie. Bonnie, how's it going?
It's good. Happy Friday. Good to see you. I'm very excited about the show tonight. And yes. I have brought these two Yahoos with me over here.
There we go, over on the side. There we go. Yeah. So Sonder is joining us once again. We've had him on several times. Always a pleasure to have him back. How's it going?
It's going well. It's going well. I'm here. I'm dressed up for the occasion. So I'm even wearing my Angular pin.
You look so sharp. I feel a slub in my t-shirt.
but at least you dressed up your microphone.
There you go. There you go. Yeah, very festive, right? And then Sam is back with us. So happy to have you back with us, Sam. How's it going?
Hi. Very happy to be here. I'm excited about this.
Awesome. Awesome. So are we. So let's see. Do the two of you want to fill our viewers in a little bit about yourself, what you got going on, that sort of thing, for people who may have not seen it previous episodes where we've been lucky to have you guys on? Maybe Sonder first.
Okay. Hi, I'm Sander. I'm Angular GDE and a Web Technologies GDE. I'm involved with Scully and a couple of other things, and I like to help people. So,
nice.
Over to Sam.
I like Sander to help the people. Teacher of the teachers.
Yes, definitely. He is an amazing teacher. I try to help people also with my mom, Bonnie. And we are working on a few courses right now that are very exciting and making them visual.
They're a lot more fun with Samantha. Samantha has actually made me a much better teacher, and everything is visual, and it's really, and this is kind of just a taste of what happens when you add a little Samantha into a project. It's really fun. So you get to see.
And there's that whole focus on the visual learning, right? That's the big thing.
Yeah, also, this is the best presentation deck I ever had for any talk. And I had to do anything about it. I love this kind of talks.
Well, it was actually inspired by a conversation that I had with Sonder. Mike Brocky.
Mike who?
Samantha's been excited to see you, Mike.
Hi, everybody.
And you too, Alyssa.
Hi, everybody. This is so great. I'm excited about this.
What are we excited about?
Everybody's here.
Oh.
I'm so excited to see you guys. It's been such a long time.
I thought I missed stuff.
No, you're right on time.
We didn't start
we were
without you.
just discussing our lives and what we do.
I appreciate everybody lying to me. Thank you.
And Samantha, your brother's actually in the chat as well, so you can say
hi. Hi, brother. Hi, Alex.
Hi, Mr. Stan. No, that's not right.
No, I'm miniature Alex. So
mini.
I've never met Alex. I'm so sad about that. We have to remedy that. Hi, Alex.
Yeah, he was a rebellious child and went to the React community, but we're bringing him over slowly but surely.
Yes.
There is nothing wrong with React.
I'll pray for your family.
There is something wrong with React for me.
Well, the funny thing about this talk is this is actually for all JavaScript developers. So even if you're a React fan, this talk still will really hit home and be beneficial because this is a JavaScript talk.
What about TypeScript? Yes. Are TypeScript people cool with this stuff?
They are allowed in for this time.
Yeah, they can watch too.
All of it, we have JavaScript hearts for everything, even TypeScript, right? So, I mean, it's the common denominator there that unites us all.
Yeah. So this talk started from a conversation that Sonder and I had. Actually, Sonder and I were, last time we saw each other in person, which was a while ago, he was saying he really misses all the people and the conferences and meetups. And he said he wanted to do another talk. So we said we were going to do a talk together. And then I
got a say in that.
Yeah. And then we recruited Samantha, and she basically did all the work. So Samantha's driving today.
I did not get a say in that.
And we can talk a little bit. I want to talk a little bit about, how this talk was inspired and how this conversation started. But we can go ahead and have Samantha share her screen if that's okay. And she can.
Yeah, should I start
show
at the
us
beginning?
Slides. Yeah. So you don't know stack,
Okay.
also known as don't block your stack.
Yes, visually.
Visually.
And we went through this. We are very happy to be here. So I handled the visuals for this talk. Sandra inspired this talk, and Bonnie brought us here. So thank you. You, everybody. And this is the question that we are kind of trying to answer. It's very... Sandra, why don't you start us off? You brought us here.
Well, actually, I can answer this question quite easily. Never. So we're done. How much time have we left? No.
And what's the question? Let's say
When
the
is
question.
Java? It's over there on your screen. When is JavaScript synchronous? Well, always. It's never async. So no, this is a talk. I was talking with Bonnie like a couple of months ago, and she said, "What do you want to teach people? What do you really think people don't understand?" And I said, "They don't understand sync." And she said, "I do understand sync," and she was warm. So
Well, he sent me to watch this talk, this JS Conf talk by Philip Roberts, and it was a really good talk. And he said it's the best talk that we've seen. But even after that talk, there were some things that I was confused about, and I did not know that I was confused. I didn't feel confused at all about this. It seemed to make perfect sense. But once we started talking through it, then Sonder helped me understand that I was confused. And he also said this is something that a lot of people are confused about, that he's come across a lot of people in his journeys who don't really understand this, and it causes problems in our code, but we don't know what's going on. So that's kind of how we dove into this. I went to watch the talk, and I came back to talk to Sonder, and it turns out I was still confused. So we went into detail about how and why, and tried to make it less actually, Samantha is the one who made it less confusing.
It was a team effort.
Yeah.
So let's do this. So on the right, we have an animation. I'll play it in just a second, but for right now, there is the shelf on the bottom with the boxes, the colorful boxes. These are the tasks, or each line of code would be a task for one of these. And this is the task queue. And up there on the shelf above with the main task, the main function, that is the call stack. So each line of code goes on to the queue, goes up to the stack, fires in the browser, and then it's done. And it's very simple. And nothing is blocked and everything is happy. Very simple. Yeah? Did I miss anything?
No, I think that's perfect. And we're going to talk through, basically we're going to talk through with Sam's animations, the code samples that Sonder used to teach us that we were confused in the first place.
Yes. And it's just going to get more, it's going to build on each other and get a little more. So this is the output. Very simple. This is sample 1, right in order. Nothing unexpected. Nothing out of the blue. This is out of the blue. Okay. It's getting a little crazy. Oh, I know what happened there. Okay. So this should not be the first. There we go. Okay. So this one is a little more complex. There are functions that call other functions. And we can see that here with going up the stack. Those call each other, and then it'll go back down because everything goes on the stack and off the stack in order. Is that correct? Nothing can go in the middle.
Yeah, that's correct. I can elaborate a little bit on that. In computer science, we use the same word over and over and over again, and we call practically everything a queue or a stack. And if we have no idea, we call it a queue or a stack. So people get confused basically because we are renaming a lot of things the same. And when we're talking about a stack, actually the call stack is not that interesting for a JavaScript developer. It just grows a little bit, and when the functions come down, it shrinks again. That is not the interesting thing. What is interesting is knowing about the task queue. The task queue is in our animations is like the gray bar, the bottom holder.
The shelf.
That is the shelf. Yeah, that is the task queue, and JavaScript always runs to completion. So it starts the program on top with the console log this, goes to the bottom, and everything will get executed in order. When the program is done, everything drops. The thing is done, and we are done. And this is only part, if you have seen the talk about the event cycle, this is a little part in that whole thing. But it always need to run to completion, because if there is any JavaScript still running, nothing else will happen. Go ahead.
So, Sam, can you play this one more time, this animation, before we go to the next one? So this one is still super simple. So we're going up the stack, but we're not doing any kind of crazy stuff here. So then on the next slide, we're going to introduce then where it gets confusing, which is the asynchronous. And before you
really quick, I just wanted to mention.
Go ahead.
Mention on that previous one, it's great to see this visual aspect of, the execution of the code, and then that going up the stack, because you're going through those function calls, right? And to see that visually, expand up, that we got to go through that chain and then we continue on to the right, like I think helps so much in making sense of tracking that code, versus say if I was to look at that code in my editor or my IDE, like tracing that through, having that mental model, I'm basically just looking at files, but this visualizes it so well.
Justin.
I love it.
Just you wait.
So this introduces basically asynchronicity.
Yes.
Oh, I love that word.
It's still a word.
So the set timeouts have the little circle balls here.
So we represented the web APIs with Rube Goldberg machines. Basically, they do one task, and they can't do anything else until that one task is finished. And they go on to a second task queue. So instead of I'll play that animation one more time. Instead of going on to the end of the first task queue, they go on to the second task queue, which is kind of like maybe a revolving door. There's always a new task queue once it's finished, once it goes to
if there are still tasks.
This was really confusing for Sam. Can you reset that? Because this was really confusing for me, because I thought, like, okay, say orange is a set timeout, right? And then and it's going to keep going down the list. Well, so what if orange is like really short? So what if orange, like, what if it's like, couldn't it come back and finish its loop and go back like before the blue block, even if it was really, so this is what I was asking Sonder, like, what if it's like 10 seconds, and what if the green set timeout is much longer? Then it would still, like, it would go next in its turn, right? That's what I thought. That would make sense to me. And so Sonder said it can never go before blue, ever, no matter how short it is, because it has to go to the next task queue. And I was like, wait, what? And I thought Sonder was confused, and I was arguing with him, and then he was showing me. So let's continue. Do you want, Sam, no, I think we're good with that. Yeah, go ahead and run it one more time, because it's cool.
So we
were trying to figure out how to visualize this in our first couple of meetings, and we were like trying to think of like JavaScript as a kitchen, and we had like a short order cook trying to keep up with everything, and we were trying to like talk through all these visuals, and we came up with the Rube Goldberg, which I think is great.
I like it.
Okay, so this one's still pretty simple, because everything is kind of happening the way you would expect it to.
Yeah, the whole idea is that you really have to memorize that once the execution of JavaScript starts, you cannot change a thing anymore. It will run to completion. You can do nothing. The only thing that can happen is an error, and then the stack breaks off and something else happens. That is outside the scope of this talk, but JavaScript will always run to completion. And when it's done, it's the turn of the next thing. Or the next task queue.
We will see a little bit of errors here. So on the yellow box, we have this timer, this while loop, and nothing happens. It's like a mini block in the stack. And then it moves on. This one resolves itself. We'll see later, just for fun, what happens when the stack is really blocked. But for right now, we have a mini block.
So if we saw something like this, where we have that while and it's going and going and going. I mean, even if we would put that, like we really want something like that, I think, to pop off the stack and go into a set timeout so that we don't have to wait for it. Because even the yellow one, it's not blocked forever, but still, Sam, can you play it one more time? Because the green one can't start while that yellow one is just kind of spinning and spinning and spinning. And I mean, at least the orange one gets to go on and move its thing, and the stack keeps moving. But that yellow one is just hanging there. And then finally the green. But even so, okay, sorry, Sam, play that one more time because I want you to see. Well, you can see, I guess. The orange one is done, right? It's sitting down there waiting. And it's never going to go until the shelf above, because it's still going to be on the shelf below until the shelf above clears, even if it's done first. And that's the part that I didn't know.
And
also, while the set timeout is like 100 milliseconds and we are waiting 1500, it is not that suddenly the thing gets inserted. It gets executed at the next stack when the entire program is done.
We still have to wait for the green one.
We still have to wait for the green one. We still have to wait for the blue one. Only when everything is done, the results of the set timeout are coming from the next task queue.
So that next shelf can never come up until the one above it clears.
And it did clear eventually, but this is my mistake. It should have risen to the starting position like the other ones, but moving right along. The output is still, everything comes back, so that's at least good.
It's perfect. I actually like for it to stop here so that we can talk through
I
it.
ever made.
It's beautiful, Samantha.
Okay, so this one, so the orange task is dispatched first, but the green one finishes first because the set timeout is much longer.
So this is pretty similar to the one that we already did. We just switched it to just visually show how maybe one can finish before the next one because they go in order that they're finished down there. So I think this is probably something that we would see kind of a lot, where one set timeout will take longer than another one. And then they switched kind of on the way down there, because even though the orange one was dispatched first, the green one was much faster, which you can see in the code. And I think this is pretty easy to understand, especially with these visuals.
Sorry, go ahead.
Go ahead.
Actually, in this talk, we are using set timeout as basically any API. It can be like a HTTP request. It can be like waiting for a WebSocket. It can be like user interaction. We just used set timeout because it makes a nice and easy sample, but it stands basically for any API call. That is async, which is basically all API calls.
I'm just having a little trouble because I tend to be a little bit like Orange and a little bit slow. But that's
okay, Mike.
To be clear, because we talked about like the size of the number on the set timeout, about how long things take. It's completely valid to call set timeout with a parameter of 0 for the time. So basically it says, don't wait at all. Just do this later. So it's basically this thing asynchronous, but you don't have to wait at all. It's just going to definitely go down to the next shelf.
Yeah, it still will wait 4 milliseconds because that's the minimum time amount that set timeout will use. And it will always go to the next task queue.
Yeah, negative would be a little bit weird because then you're talking about time machines and let's not.
Yeah, JavaScript is very easy there. It still uses 4 milliseconds.
Are we going to cover at some point and then talk what all goes to the second task queue versus not? Like, is there like a quick list online of like
reset that animation? So in this illustration, basically anything that has the little circle will go down to the next one, and that would be anything that will trigger. It's going to be HTTP call, XHR, and set timeouts, right?
Set interval and promises as well.
Yeah.
Promises are a little bit special because promises are not going to the next task queue, but they will be added on the end. It's a little bit outside of the scope. These promises are micro tasks, and I left them out for a reason because those are confusing in this whole setting. But they are they are a little bit different. But really, what you can see is like, okay, most of the APIs are async and will always go to the next task queue.
Okay.
JavaScript is done. The browser does this whole dance. It's going to paint and update and everything. And then it says, hey, I'm done. JavaScript, do you have anything to do? JavaScript looks at its task queue and says, yes. And it will go as happy as you may.
Okay. Perfect.
I think we are ready for the next one. Yeah.
So
What are we looking at in this one?
this one,
Yeah.
we've got a ramp here that is not physically with physics. It's not going to go down to the next one. It's never going to finish. So
Can you stop the
it
animation?
breaks.
Can you stop it for a minute? Oh, no.
Yes.
Because this was where I was really surprised when I was talking to Sonder before we had these animations, and I like, what do you think is going to happen? You know, I thought that it would not proceed because if the orange ball never drops, then what will happen?
Good question. Will the green ever make it to the top queue?
Because the orange, so the orange ramp is broken here because you see that last orange ramp is like at the wrong angle. But say it's a bug and that set timeout never completes, then what's the next thing that will happen? Will it fly up or will it skip over? And I didn't know, but it's
actually basically straightforward. Anything that happens outside of the outside of the task queue is no concern of JavaScript. So somewhere in the browser, something falls off. If it's like an HTTP request and the server says, nope, I'm not going to send you anything. And the browser says, but please. And the server says, nope. Then something happened and you will never get an answer back. And
I really want a GIF of Sonder going, nope. And I can just use that in so many different situations. Okay, so go ahead, Sam.
So it will go to the top. That one disappears.
So the orange ball goes away, and it's like it never happened, and it just proceeds without it. As long as it's down off of the, as long as it's not in the stack. So yes, Thomas, you're absolutely right. Thomas said the orange would just not get added, which is right. So it just continues on without the orange.
Yes.
So this one, though, because that's the thing, is the name of the talk was Don't Block Your Stack, right? So we wanted to make sure that we had an example of what would happen if, because remember on the yellow one before was just spinning and spinning and spinning and spinning. And so then we said, what would happen? So we went back to talk to Sonder and we had another meeting and said, what would happen if it just never completes, right? If there is something on the original stack that's not in a ball that doesn't roll off and it just gets stuck, what does that look like? And we asked Samantha to like make a picture to go with Sonder's code, which was really fun for her. This is like the best slide.
Yeah.
So everything is going as normal. Then the stack is blocked.
Samantha gets joyful when we ask her to make things break because it always breaks in fabulous fashion. So yeah.
Some people just want to watch the world burn.
Yeah. Yeah.
At least it's digitally.
This is basically a developer that is using an Apple computer, and when you are just repeating yourself, the fan will start spinning, and after a while, this is what will happen.
Fire!
Okay,
And
so
it will never complete.
if you have a function that never completes that's up on your stack, then nothing's going anywhere. It's broken, and nothing's going to happen after that.
Yeah, this is
Things will happen.
Yeah, things will catch fire. What happens if you keep on repeating? If you are in a loop and you keep on repeating, your entire browser grinds to a halt, and even your mouse will not be responding properly anymore. No clicks will get generated. Nothing will happen anymore. And that is the reason why everybody is calling, hey, don't block your stack. But what is actually blocking your stack? Yeah, like endless loops. And nobody would, in his right mind, would make a loop like this. But what happens is, okay, I'm getting the results back from my backend. Oh, 1 million records. I'm going to process them for 1 to 1 million. And I'm going to loop over a ginormous data array. And I'm doing a boatload of processing. All the all that while, there is nothing else going on. The browser will completely block. So don't do this. It's easy in a simple example like this. It's a little bit harder to detect in a big application.
Yep. Okay, so let's go to the next slide. I want to talk through our process for this because it's actually, I've been teaching Angular for a long time, right? And I usually teach with VS Code. I think like most of us do, and we go through back and forth between VS Code and samples. But we started working on this talk, and we were trying to figure out how to show it visually because this is something that Samantha has brought to my teaching, and I really like it. And but it's hard sometimes because I'm not visual so much. So, but Sonder had this idea when we first talked about this. He said, "Imagine, Sonder, what did you say? Imagine a guy scooping ice cream." And can you explain to them the way you explained it to me with the ice cream scooper guy? If you have an
ice cream scooper guy, I said the JavaScript is the ice cream scooping guy. So he is in his stall, he's selling ice cream. So our customer walks up, he takes the order, he's noting down the order, he is doing the payment, then he goes over, scoops the ice cream, hands over the ice cream, and so on. You can imagine that JavaScript is single-threaded, single task. So you can imagine that there will be a line up there. And the way I was going on it, okay, he gets more helpers, so he shows up the scooping into a function. So we have an extra scooper and so on and so on. But when we started to work this out, it became harder and harder because it is really, really hard to create a proper analogy for this.
Because he was saying, the conversation started with RxJS. We were talking about doing a talk about RxJS, and then we kind of went down to like underneath that because he said it's actually even confusing before that. Because the thing is, if you imagine Sonder's analogy of one ice cream scooper guy, then no matter even if you're putting like RxJS and state management, NGRX, you're putting all that stuff on top of it, but then you've only still got one guy scooping ice cream, which is down in the JavaScript. And so that's where, if you don't understand that part, then no matter what you're doing with above it, with all the helpers around, you've still got that only one guy. So we actually started with that ice cream scooper example, and we had like, okay, in the beginning you've just got this one scooper, and then you add like the task queue was going to be like this kitchen staff, and then the fire was going to be like the cook behind the kitchen crying and smoking, and it was just all getting really crazy and complicated. And that's when and Samantha was like getting stressed out because she's in charge of all the drawings. So we actually simplified it back to the Rube Goldberg. And I think she didn't want to make a full motion animation film. I don't know. Well, she would have.
It'd be
anyway,
nice.
Yeah.
This whole process of teaching visually, I think, has been really fun, and we're going to continue doing this. We're doing more courses. Samantha is really fun to work with. Samantha, can you zoom in on that one picture? Because this was actually one of the meetings. So the first meeting I had, oh yeah, that's one of our bloopers. The first meeting I had with Sonder, Samantha wasn't there, and we were talking through the code, which is the same code that we showed you guys today. And it was like, it was really interesting what he was showing me, because I've been doing JavaScript for years and I thought I understood it, and I didn't, right? I was like, what? Sonder, what are you talking about? But it was still hard to picture everything just with, it was interesting, but it was hard to like kind of understand what was going on where. And so we brought Sam in, and I asked Sonder to show Sam what he showed me, and Sam made the same face that I made.
Exactly the
which
same.
You can see right there. She was like, what? Because
I probably had the same evil grin.
Yes, you did. Because he would stop and say, what do you think is going to happen? And then we would get the answer wrong every time. And then he would run it and we'd be like, what? So, yeah, that was fun. But hopefully you guys did not make that face, because you got to see it with Samantha's animations, which I think is much, much nicer. So thank you, Sam. And I just want to tell y'all, I am so proud of Samantha, because you guys have known Samantha for years. So back when she first started with the claymation, and how far she's come. So go, Sam.
Thank you very much. Any questions?
Yeah, that's our talk. I told y'all it was a short talk.
Yeah, so questions are welcome.
Yep.
If there's anything confusing, let us know. Yeah, basically.
I think we did a bang up job. Nobody has any questions.
Thank you very much. Go us. Go team. Well.
So what? Here, I'll take off the screen share here. We can go back to the little panels. So when we think about like we're building our applications and we're writing this code and we add some set timeout or whatever, what are some of the things that we kind of might experience right now? I think like the value of this talk, right, is to help kind of get that understanding of what's going on under the hood, so you can start diagnosing things like, I created a set timeout with 100 milliseconds, yet it doesn't seem to respond for like 3 seconds, right? Why do I not see the result of that? And what we kind of went through here is that you can see that other things on the stack could be the ones that are blocking that, right? And so it's not that you set your milliseconds on your set timeout to the wrong value. It's that you actually have something else going on that results in you not seeing the end of that set timeout logic code, right? So I don't even know what my question really would be there, but like how do we kind of start thinking about these things and from a debugging standpoint? Is there any kind of advantage that we can get of say, hey, look, okay, let me think about if I'm using set timeout or set interval or any of these things, should my mindset from a developer, from a debug standpoint go, okay, start thinking about the stack right away, because that could be an issue?
Yeah. Let me first tell about how set timeout works, which seems a little bit silly, but really when you do a set timeout, you're calling an API, and the API is inside of the browser, and you ask that API, hey, after 100 milliseconds, can you run this function for me on the next JavaScript task queue? That is the full thing. JavaScript is doing this a little bit faster than I'm telling it, but that is happening. And then the browser said, sure. And he goes, watch. And he will, after 100 seconds, he will put it on the next task queue. So it will be there. You've seen this in the animation. It will be put there. But what happens if you're quite busy in the stack and you're still processing things and so forth? It will just be waiting on the next queue until your whole program is done. What people forget about set timeout is not a function that is doing the waiting. Set timeout is just saying to the browser, do this, and then goes on directly, which is the same as with a promise. If you set a promise, it will go ahead directly. There is only one exception, which I will not mention here because it is confusing.
Well, now that you mentioned it, you have to at least tell us like what it's called. Don't leave us hanging like that.
Okay, it's called async await.
Okay. And so how would async await work? We should make a...
Async await basically works the same thing, but it reads differently. And that is where people get trapped. Because you see, okay, I'm running a async function and I'm getting on an await. And then people think, okay, that thing is really going to wait. That is actually not what is happening. It's going to park it on the side, the whole function. And it does the thing it's awaiting. If you await a set timeout, the browser is going to, okay, oh, I'm done. And then we'll put it on the next stack and it will be executed. But you read it like, okay, it's waiting for that, and then it's going to do that, and then it's going to do... That is actually not what is happening. It's actually, okay, an await means park this thing away and get back to it later. And the stack keeps on going. As soon as there is an await, basically, it parks the thing away.
And then when it triggers, then it jumps back in.
When it's coming back, it's going to fetch it back and resume execution. That's what the await is called. It's actually opposite of what it is doing, because it is. But for the readability, it makes sense to read it like that. It's okay, you can think about it as it is waiting for that, but it's actually not what's happening. It is not blocking. And now I've lost completely my train of thought.
That's okay. Alex Alonso wanted to know in the chat what would happen if there was an unfinished task on the second queue. But there can't really be an so there can't, because it won't go to the second queue until it's finished. So if it
Exactly.
doesn't finish, like that one that we showed in the orange that just went off into La La Land, if the set timeout comes down to the second queue and it never finishes, then the queue, when it's time, when the first queue finishes, the second queue will go on. And then if the other one ever shows up, it will, because once the shelf has started and you've activated the first box in that shelf, you can't add anything to it once it's started. So anything that happens after that first one has started will go to the next task queue. And if it's even if it has to go to the third one or whatever, it's whenever it's done, it's going to show up in the next task queue.
Yeah, and I go back to the server example I had. If the server is not responding, because that is actually the most common case when you encounter those things, the server just is going to say, nope, I'm not going to answer you. And you are never going to get called back. That's why it's called a callback. So your promise is never going to be resolved, but it is also never going to error. So it's unknown. And that is something you might want to take in account, and you might want to make sure if you have calls that have a possibility to go wrong, that you add some timeout around it or some other way, so you know that it is still somewhere out there.
Like that yellow one that was going and spinning and spinning and spinning. If it had been in a set timeout, then everything would have been. See, this is the thing I think with JavaScript and Angular is they're inherently so fast that you can make mistakes like this, like that yellow thing there that just kept spinning. You can get away with that because it's so fast, but some people don't realize like that they're actually writing these delays into their own code. And I think that one example was good where, you know, it just keeps on spinning and it's slowing down the whole thing, but we might not catch it unless like the last one where everything catches on fire, like you're going to catch that immediately because nothing works. So you know immediately that, you know, you have to fix it. But if it's something like the yellow one, like that's the kind of thing that could sneak in and we wouldn't even realize it. So having a good understanding, like, and even when you're writing this code, like anything that you think might take a long time, you want to go ahead and kick it off, you know, and let it come down to the next task queue. And so doing a set timeout instead of a while loop would say, instead of making everybody wait for this while loop, we're just going to go ahead and come back to it and let it tell us when it's done. So that's kind of, I think, how you need to change your mindset with this understand. But it's like, you know, you don't really know that it's confusing until you know that it's confusing. But that's the kind of thing where if you kick it off to the next task queue, then it'll actually keep everything running smoother. The Max Guild said now introduce request animation frame. It gets even more confusing because it's another different queue from micro and macro tasks. You know what this means? Like the longer we talk about this stuff, you know what I think? Samantha needs to do more animations for us.
That's what I'm hearing too.
Question about what Sander mentioned with how sometimes you might just never hear back from the server, and so it's good to set that like around maybe like a set timeout, and then you get an error, like your own created error, I guess. Is it possible for you to time out the thing, but then later on you still hear back from the server? Like, or are you never, like once you call that set timeout and you're like, we're never hearing back, you've like closed the gateway.
If you write
what happens?
With a set timeout, you actually cannot close the gateway. If it like hours or days later it says, hey, I have something, here you go, then JavaScript goes, okay.
Wait, really?
And
just like, and then you have it and then it's yours?
Exactly. One problem though, probably you have lost all context of that whole thing. And JavaScript goes, oh, what the heck? And your program still fails. So, yeah.
It's like when you order that pre-dinner salad and then it shows up.
And you're like, what?
Like, I can't eat lettuce now. What are you doing? Thanks, JavaScript.
Yeah.
That's fun.
So, you know what, not to put any more like requirements or expectations, but what I really, really want is I want a IDE or editor plugin that will look at a block of my code and visualize it just like what we've seen with the cubes and the task queue and the things going up visually. Like, how awesome would that be to be able to say, hey, here's this call stack, go and give me a visual representation.
We'll call it VS Sam.
Plugin. Yeah. I'll get right on that.
It is actually doable.
Yeah.
Everything is with Sandra on your
TypeScript
team.
and everything. Yeah, you think, right? I think that it's so valuable because one of the things we do a lot as developers is try and do this mind map of our code, right? And we start talking about things like event systems and things like that. It becomes even more and more challenging for us to visually look at our code and understand mentally what's going on, right? And where this is the business logic. And so we do a lot of times, we'll do things with the way we write code and classes and things like that, interfaces, to try and encapsulate that, to help that more readable or more understandable from our mental mapping of the logic. But maybe it's freeing ourselves from that by being able to visualize it in this other way, right? Like a lot of times I'll think about, hey, I need to like be able to grok this understanding of these three pieces of business logic. And so there's not really a way with an event-based system to kind of encapsulate that. So I write some code that defines that, to help encapsulate that, right? But kind of, am I writing that code just to help the developer to understand that by reading it? Is there another way? Is there another tool like this where I can say I can rewrite my code the way if I need it, and then I run this tool and visually see it?
Yeah. I understand what you're saying. The other side of this is that we've talked about this a lot from the negative side of things of, hey, this isn't reacting like I want it to. Something's wrong. I did something wrong. I think there's a whole nother side of it to think about when it's basically, I want this type of behavior. How do I make sure that I get this to happen the way that I want it to and when I want it to?
Yeah.
So don't always think about the asynchronicity and the way this runs as a negative. You could think about it as a positive. Hey, this is how my application is going to run. How can I take advantage of that to get the experience and the results that I want?
Yeah, the thing is, you first need to know what can blow up before you can make use of the thing. Like if you have a big blob of data you have to process through, you're not going to do a for next. And if you're using a set timeout to push it to the next task, you are just procrastinating the problem to the next task. You need to cut up your task in like smaller blocks and say, hey, I'm going to do 100 now. And then I'm going to do a set timeout. And then I'm going to do the next 100. And then I'm going to do a set timeout. And then I'm going to do the next 100. So you give the computer, the JavaScript compiler, some air to breathe. A set timeout of 4 milliseconds is a really long time for JavaScript.
But at the same time, maybe you're doing an operation and the user did something, you want to be able to log something. You want to do something where I'm sending something to the server that's not really pertinent to what I'm doing. It's just kind of like logging. Like I want to let the server know that something happened, that the user did something, right? Well, I think it's more important for the processing to get the user back what they need within that function and maybe put the call to the server. I know it's going to make an XHR request back to the server and what have you, but at the same time, let that all happen later. Let me get back to the user with what they need, and then this can be done later. It doesn't have to be done immediately. I want to be able to keep that 60 frame per second mindset and get the user the feedback that they want as quickly as I can, and then get the other information logged back to the server.
Yeah, like you said, it's a positive thing. It's a tool in our tool belt, right? It's like when you finally understand the matrix, you can make that spoon bend, right? So it's something that's empowering us to solve problems and do solutions by really understanding.
Now I know what's happening to my spoons.
They're just bending. You're like, whoa.
Crap.
Too powerful.
Yeah.
Justin and his spoons.
You need to just keep finding those bigger spoons, right? Those giant spoons, and then make it a little more challenging and just.
I switched to wooden spoons.
I was going to say, you don't once you start bending wooden spoons.
I can't stand the feel of wooden spoons. I can't touch them.
Oh my God, that's such a. I love that. I love tidbits like that. Any
those little ice cream cups that come with the little wooden spoon. Oh my God,
they are.
Yeah.
The plastic one.
Oh, even that. I was imagining like
that
big
too.
cooking spoons.
No,
you're talking like
any type of wooden surface utensil. I don't know. Like Like regular wood, I could work with wood and everything's fine, but those, I don't know.
Oh, that's funny.
I can't blame you. They're pretty bad. The ice cream spoons.
Justin, did you have a bad experience when you were a kid?
Yeah, obviously I put those spoons in my mouth and that was it. Done.
I wasn't sure if you were eating ice cream and got a splinter or something like that. It's like, that's it, I'm done. No more ice cream off of spoons.
I mean, that's certainly a possibility. Maybe I just blocked it out and I'm like,
That's such a bad splinter incident that it's like blocked.
Right?
It's
I'll
blocked.
stop talking about it. Sorry, Alyssa.
Did you see what Thomas said? There is no stack.
Alex says, "What about big wooden spoons for cooking?"
Yeah,
I think that,
no.
yeah,
He said
I
those
think
too. Yeah.
you just can't.
yeah,
eat
those
off
are
of
out.
them.
And like microfiber towel. Okay, what else we got to talk about? Anything?
No, I'm with you on the microfiber towels. I hate touching those. I'm
I
so
love
on that. with you.
microfiber.
It's like an injury. Like I can't even watch you touch that towel. It's
It
like,
makes me hurt inside.
Oh
Everywhere.
wait, let's talk about how come you have these microfiber towels just on your desk,
On
ready to
your
go? Like,
desk.
What-
Why?
I'll take that one. I have
no! I don't have any
dry erase markers and a glass surface that I can write on, and this is my eraser.
I
I
have
have
baby
lots
ducks.
That's better. Much better.
All right, well that answers
Okay.
that. We're full of answers here on the show. I love it.
Oh my word.
Oh, and I also have an Angular Connect spinny thing. Remember
Oh,
that's
are we
like
now
so...
talking about random crap on our desk? Like a useless box?
You guys remember?
Those are amazing. You have a
No, I love those. They like switch it off. Do it the other way. Show it like twist it that way. Yeah. It's so cute.
What's happening in there?
The little
He just
hand
flips the
comes
switch again,
down.
Sandra. He flips it and then the thing flips it back.
The box flips it back. Yeah,
Sam didn't see it,
Look,
Sandra.
look at the switch.
it's really
If I,
fast.
if I turn it on, it turns it off.
It just closes. It just. All right. Okay. I'm with you.
It is completely useless.
I love it.
All right,
too.
we have a
That's why
hard
it's on
stop
my
at the
desk.
top of the hour. We better get into picks, guys. We're running out of time.
Yeah, let's do it. Let's check with our panelists first for picks.
I
Mike,
have
you
a
have anything?
pick.
Well, Sandra, you have to wait because you're a guest, so all the guests get
Yep.
special
Save
treatment
the
with their
best for
picks.
last.
They come at
Sandra.
the yeah.
So
Yeah.
Leander.
Okay.
Sandy, your pick's in a set timeout, okay?
Yeah.
Cover thread.
I have one pick. I haven't purchased it yet. It's on my to-do list. But if anybody read or listened to or saw Ready Player One, Ready Player Two was released on audiobook a week or two ago. So if you loved Ready Player One, go check out Ready Player Two, now available on audiobook. And it's
How do I
all.
watch an audiobook?
What's that?
How do I watch an audiobook?
I said watch out.
With your mind.
How
With
do
your
I watch an
mind.
audiobook? How do I do that on my television?
It's a challenge.
Yeah, the same way you visualize the stack. You just
Yeah.
have to build that animation.
Yeah.
Oh, okay. So I hand over the book to Sam, and she makes.
Sam, you got a lot of things on your task queue.
I
now.
wanna-
It really does.
Yeah. That's
I think you can make some serious money this way, though.
Yeah, that would be very
Go
cool.
ahead.
Pixar, hire me.
It's also narrated by Will Wheaton, so same quality.
What?
Yep.
the Will
That's
Wheaton that was in
amazing.
Big Bang Theory.
Yep.
Yes.
Double dubs.
Wow. He was in some other stuff a long time ago too. That some of us remember.
But
Oh,
he's
yeah.
famous for the Big Bang Theory, Justin.
I
No.
don't know.
Yeah, I mean, is that really?
I think he's famous
Just
from
depends on
Star
how
Trek.
old you are.
I know
Star
him
Wars?
from Big
Star Trek.
Bang. I don't know what to tell you.
Oh, you youngster.
I mean, if you're a very young kid that wanted to be running around on the deck of the Enterprise or any ship like that, then you might remember him from that opportunity. I don't know.
I think if we pretend that we don't know what show Will Wheaton was on before the Big Bang, these guys are going to get really hostile with us, Alyssa.
I'm fine with it.
He used to walk up the hill
I'm on
both
mute.
ways in the
Hey,
snow.
there will be a time that there are real life meetups again.
All right. Alyssa, do you have any picks?
Yeah, so I've been getting into reactive forms lately. I've been avoiding them like
Are you okay if I interrupt you during your pick?
Yeah, do it.
Okay, correct.
Wait, what?
I'm gonna let you finish, but
Is this like the stack thing? I don't get it. Yeah, I have been getting into reactive forms. So if you haven't, check out Maximilian's course on Udemy because it's really cool. I love it.
Nice. I like me some reactive forms as well.
don't you also have a reactive forms course, Justin?
I might.
On
Where is
LinkedIn.com.
it at?
One
What
of
is it
those.
on? Which place?
It's on LinkedIn Learning.
That's it. Oh, I'm
And,
so excited. I'm looking it up right now.
That's actually where I learned about reactive forms originally.
It's a good course.
LinkedIn.
Oh,
Learning.
thank you.
Well, let's not get mushy here.
It goes through. It goes through making a form for a sandwich shop to make custom special sandwiches.
Yeah, so bring a snack.
It'll get you hungry. You'll be hungry. All right, I don't have any picks, so let's go to our guests. Sandra, you got a pick?
I have a pick. I have a YouTube video that everybody should watch. I linked it in the private chat, so you can share it out.
What is it about?
It's about a bunny in Christmas. And
A
it's
bunny
a
on
really,
Christmas.
really,
All right.
and it's a really, really sad song. But probably you will laugh your ass off.
Okay.
If this is gonna make
It's
me
an
cry,
original
I'm
Dutch
not
one.
watching it.
It's translated from Dutch to English. So you all can
Listen, is the bunny alive at the end? That's all we need to know. Like, does the bunny
I'm not going to
survive?
spoil the surprise.
What are we
but
getting into, right?
I have a feeling I'm about to get rickrolled.
All right, Sam, do you have a pick? I have a pick. I should have gone.
Well,
I should have been the last panelist, but I'm also a guest panelist. So, Sam, do you have a pick?
Yes, it starts in 6 minutes on
Yeah,
Angular
that was
Nation.
my pick too.
Yes. Well, you should have been the last panelist then.
You
Tell
stole
us more
my
about
pick. Yeah,
us more.
so every Friday, we started this a month or two ago. Every Friday, right after AngularAir, we do a community hangout on Angular Nation where we invite you guys watching to come and turn your cameras on and hang out with us. And so we're going there in 5 minutes. We're going to take a quick break and we're going to go there. We're bringing Sonder and Sam, and the rest of you are invited as well. And also, guess who's going to pop in and join us tonight? Ben Lesh and Tracy Lee from the RxJS team. So it's going to be an RxJS kind of night. So go join AngularNation.net. We'll watch if there's anybody new who's not already there, and we will try to click on those and get you in so that you can join us in 5 minutes.
Awesome.
It's going to be great.
Awesome.
Yep.
For sure. For sure. Well, hey, Bonnie, thanks for being a guest today on our show and helping coordinate this. And
You're welcome.
Sander and Sam, thank you so much for coming back on, sharing all your knowledge. The presentation was killer. We learned a lot. So very, very thankful for you taking your time and sharing your knowledge. Thank you.
Thank
You're
you.
welcome. It's always fun to be here.
For sure. And until we meet again, take care, everyone. Later.
Take care.